welcome to the first TACC system introduction. This is a new webinar series that we're starting where we introduce our clusters, their hardware, their respective file systems, and by the end of the webinar, users will know how to run their very first job on TACC systems. Today, we'll be going over a machine called Stampede3, the third iteration of the Stampede series. This is a National Science Foundation funded project, and we have users from all across the world working on this machine. If you would like to follow along at home, we'll be going over TACC documentation of the Stampede3 user guide. So let's get started. The first thing you'll see at the top of the user guide is notices. We're very excited to have recently added 24 NVIDIA H100 GPU nodes that are now accessible for Stampede3 users. The next section is an introduction with a thank you to the National Science Foundation for the generously awarded grant to the University of Texas that funds Stampede3. Please reference TACC when using any citations for your work. So let's take a minute to talk allocations. In order to use Stampede3, you need more than just a TACC username and password. You also need an approved allocation. Getting one of these allocations can be done by visiting access-ci.org and going through their allocation process there. Fortunately, they have great documentation and excellent get starting videos to help you out. Now, on to the next section. Whenever we talk about a modern HPC system, we're primarily talking about dozens, hundreds, sometimes even thousands of different computers linked together, each individually called nodes. These nodes all have different roles inside of the cluster. Some of them are login nodes, which is how you connect to the cluster from your local machine. Some of them are storage nodes that manage data, but a majority of the nodes inside of the cluster are compute nodes. When we bring back our Stampede3 documentation, you can see that we have several different compute node types on the cluster. Compute nodes are where your jobs should be running. The first of our compute node types that we have listed are our Ice Lake nodes. Each of these Ice Lake nodes is equipped with 2 Intel chips for a total of 80 cores per node. Let's take a minute to talk cores. What does that mean? And the best analogy is that each core is equal to 1 chef working on a recipe. But these Ice Lake nodes could have 80 chefs working on 80 different recipes. And that's quite an impressive feat. If I were to look at the statistics from my local machine, you'll see that I only have 12 cores running. So I can only have 12 chefs working on 12 recipes at a time. Each of these nodes inside of the Stampede3 cluster is more or less a supercomputer to itself, capable of doing many more processes at a single time than your average at-home machine. As we scroll through the user guide, you'll see that we have several different compute node types for users to choose from. These different compute nodes have different charge rates depending on the partition that they are in. We'll come back to charge rates when we discuss partitioning later. Also, you'll see that we have 2 different GPU types to choose from, NVIDIA H100s or Intel Ponte Vecchio GPUs. And finally, you'll see a note for the description of the login nodes. As previously mentioned, these are how you connect to the Stampede3 supercluster. Following the description of the login nodes, we have a section on the network. This network is a high-speed interconnect that connects every node inside of Stampede3 to every other node inside of Stampede3. Currently, the interconnect is the 100 gigabit per second OmniPath network. And I can say that as of this recording, we are currently installing the OPA 400 from Cornelis Networks. The next section of the user guide is perhaps one of the most important, the file systems. File system is the backbone of any HPC system. And Stampede3, users have access to 3 different types of file system. The first one is home. It's a smaller amount of space, but it is backed up regularly. If there's anything that you consider vital to your workflow, it should be saved here. Next is /work. This is a terabyte of space, and it's mounted across all TACC systems. These are for your larger data sets, and it's important to remember that this is not backed up. And finally, Scratch. Scratch is intended for high I/O. There's no quota for your data sets here, but it's important to remember that this is subject to TACC's purge policy. We'll be scrolling over that since it's a bit out of the purview of today's class. Once you are associated with the project with an active allocation on Stampede 3, you can now access the system via the login nodes we discussed earlier. There are many ways to do this, but one of the more traditional is SSH via a terminal or an application like PuTTY. Another common option is logging in to Stampede 3 via the TACC analysis portal at tap.tac.utexas.edu. The next section in the Stampede 3 user guide addresses account administration. The first is the type of Linux shell environment that you will see whenever you first access Stampede 3. By default, we have it set to Bash, or the Born Again shell. If you would like to change your shell environment, you can do so by opening a support ticket. Following information on the environmental shell, we do have a diagnostics tool installed at TACC called Sanity Tool. This runs account-level diagnostics that is designed to detect common account-level issues that may be present in your environment. To use this tool, simply use module load sanity tool, followed by the command sanity check. And finally, we have instructions on setting variables. At any point, you can check your current variable setting by using the command env. The next section under account administration addresses modules. At TACC, we created and maintain a package called lmod. This has several functions, one of which is making reproducible science easier with set versions and set variables of different modules. Another is to make life easier for our users. Instead of everyone installing their own compilers or applications, we have many module packages already installed. And they can be found in several locations. Either A, at the TACC software list, or using a command called module spider. Depending on the application you want, we likely have several versions available for reproducible science purposes. And we have a series of commands here on the Stampede 3 user guide that shows different lmod commands, such as module avail, module spider, and module save. Next, we have a section on cron tabs. Please note that cron jobs or cron tabs do not propagate to every login node and are unique to the login node that they were created on. If you would like to reach that specific login node, you can do so with an exact SSH command to the exact login node. And then we have a nice little module called TACC tips. Using the lmod commands of module load, TACC tips, and show tips, you can find fun and useful commands that could help you in your everyday TACC system usage. We're going to take a deeper dive into file systems now. On Stampede 3, users primarily are working with one of the three following file systems. Either their home directory, which is 15 gigabytes, their work directory, which is 1 terabyte, or the Scratch file system, which has no quota. It's important to note that only home is backed up regularly. Neither work nor Scratch are backed up. Work is intended to store large data sets, but is not intended for high I/O. Scratch is what's intended for the high I/O data sets and input-output. If you're not familiar with the Unix file system setup, it's important to understand that everything is a file, whether that be a hard drive, a directory, or a text file, As far as Unix is concerned, they're all files. This might take some time to get your head around, but I found one of the best ways to understand it is to use the command tree. The tree command creates a drop-down of directories and files inside of those directories. And I've found that this helps understand the hierarchical nature of the Linux directory trees. As always, we try to make things as easy as we can for our users. So every user has these built-in account level aliases already set up. So if you would like to navigate to your home directory, you can do so with cdh, or to scratch or work with cdw or cds. And then if you need to share files with collaborators, we do have a separate page for that goes over Unix individual user permissions, file permissions, and group permissions. Please see that page for further information. Okay, so you have access to Stampede 3 and understand the file systems. Well, now it's time to start running jobs. We're going to jump around in the user guide just a little bit here because I'd like to start running what I consider the simplest and most user-friendly type of job to run, an iDev job, or an interactive session. This is something that users use to develop their code or to run a series of quick and simple jobs. As you can see, I'm logged in here to Stampede 3. I'm going to type in a command called iDev, I-D-E-V. Depending on node availability, it might take a few minutes for this iDev job to start, but once it does, you'll see that I'm logged into a node. And from here, I'm going to do cds and change to my Scratch directory. And I have this file here called coinflip.py. And this is a very simple Python script. All it does is flip a coin 1,000 times and output the results. So, just like that, you can see the results. And this is how easy it is to run a job on TACC systems. Let's come back to the top of the running job section. You'll see the next topic discussed in the user guide is job accounting. And this was when it becomes important to start understanding service units. Every project that is awarded an allocation on Stampede 3 is awarded a certain number of SUs. Think of these like node hours. And different nodes have different charge rates on them depending on the queue. The formula for finding the SUs used for a job is the number of nodes that you have, the job duration, the charge rate of the said queue, and then that will give you how many SUs your job used. When we scroll down a little further, we see the queue partitions. These are primarily split up by node type or GPU type and have different charge rates that vary on a variety of factors. Underneath the different partitions, you'll see the section for SBatch. This is perhaps one of the most important sections of this entire user guide. It would be quite inconvenient for you to have to wait for resources to become available for you to run your jobs. So at TACC, we use a job scheduler called Slurm. And in order to use Slurm, you'll need an SBatch file. We have several of these on the user guide for each queue that you might want to run in. But for now, I have an example here in my Scratch directory called CoinBatch, and we'll take a look at that real quick. You can see SBatch followed by a series of arguments. For example, we have CoinFlip, which is the job name, an output file, an error file, the partition that I want to use, in this case, Skylake. We have the number of nodes that I'm requesting, along with the number of processes that I'll be having. And we have a runtime here. Slurm has a feature called backfill, and it will do its best to always keep the queue full as resources are available. I highly recommend that you set this time for however long you think your job will need, and Slurm will schedule accordingly. I also have my allocation listed, and at the bottom, you see that I have coinflip.py, which is what this SBatch script will execute. So I'm going to exit out of this Vim session and run SBatch coinbatch. And it might look like nothing's happened, but if I run sq-u and my username, you'll see that my job is in the queue. And once this job completes, I'll get an email sent to the email I have listed, and I'll be able to see the results by checking the output file. Following the instructions for submitting jobs with SBatch, we have a table for common SBatch arguments. You can use these whenever you execute the SBatch command or have them inside of your SBatch script. If you would like to learn more about Slurm and its arguments, how the scheduler works, or general Slurm commands, please see Slurm documentation. Scrolling down through the Stampede3 user guide, we see the section on launching applications. We'll be skipping over this as this webinar is designed to be a general use introduction, and each one of these subsections is unique to different users and their goals. And with that, we're back to the section on iDev, which we covered previously in this webinar. Finally, one of the last things we'll be discussing today is software. On TACC systems, we have a large array of software packages already installed, and you can find them on this page for TACC software. But due to the vast array of software suites that HPC users have access to, there's no way that we could support them all. So we allow users to install their own software packages. We have instructions to do this in TACC documentation. On Stampede3, we have the Intel compiler set as the default recommended compiler. We also have the GNU compilers loaded as well. In addition, we take advantage of a tool called lmod. Let's get a quick demo of that going right now. As you can see in my terminal window, I'm logged into Stampede3. I'm running a simple command called module list, and you can see all of the modules and software packages I currently have loaded. You could also just type ml. So if I want to see everything that lmod has access to, I can type in the command module avail to see a list of available modules to be loaded. Or I can type in module spider, and that'll also give me a list of available modules. And if I want to learn further information, for example, let's say PyLauncher, I can type module spider PyLauncher. And then if I want to load PyLauncher into my environment, it's as easy as module load PyLauncher. Just like that, I have PyLauncher in my environment. This is something you can set via the command line or via your SBatch script. I'd like to thank you for joining today's Stampede3 System Introduction webinar. If you have any questions, feel free to open a help desk ticket, and I ask that you like and subscribe. We'll have more of these system introductions coming soon, along with other support videos and helpful topics. Have a wonderful day.